Question 2 is a little different from question 1. In question 1, given a z-value, we wanted to find the associated probability or area to the left or right. In question 2, we're given the area to the left or right, and now we want to find the z-value corresponding to that. So let's start with part A. We want to find the z-value such that the area to the left is 0.1762. In other words, the probability of seeing a z-value less than that is 0.1762. So we know that the area to the left is 0.1762. We want to find the z-value here. Well, I know that the table gives me areas to the left, so if I look for the area of 0.1762, I should be able to just read off a z-value. So I'm going to go to my z-table. Now, instead of looking at the z-values, I want to look at the areas, so the probabilities here. So I want to find area to the left of 0.1762. Well, I see that right here. So I know that the area to the z-value corresponding to an area to the left of 0.1762 is negative 0.93. Negative 0.93. So this z-value here is negative 0.93. Next, instead of an area to the left, we're given an area to the right. So I'll draw a new picture. Now I know the area to the right of some z-value is 0.1. Oops. Well, the problem here is that if I want to find the z-value corresponding to this using a table, I have to look at this in terms of area to the left. So this picture is exactly the same as this one. It's a big area. It's going to take me a little while to fill in. Let's see. Okay. In other words, for my z-value, having an area to the right of 0.1 is the same thing as having an area to the left of 0.9, right? Because 1 minus 0.1 is 0.9. So if the area to the right is 0.1, area to the left is 0.9. So now I can find the z-value corresponding to an area to the left of 0.9. So I want to look for 0.9 here somewhere. 0.9, let's see how close I can get. 0.9032, 0.8, okay. So these two are my closest to 0.9. This will happen sometimes. You won't find exactly 0.9. So we have 0.8997 and 0.9015. This one is actually a little bit closer. So the z-value corresponding to an area to the left of approximately 0.9 is 1.28. Alright, last one, part C. Part C asks, we want to find the z-value corresponding to the 46th percentile of our distribution. Well, first let's do a recap of what a percentile is. If you remember when you took the SAT, you got a raw score and you got a percentile score. So let's say you scored at the 46th percentile. What does that mean? That means that I scored higher than 46% of people. In other words, I did better than 46% of everyone else who took the test. In other words, 46% of people scored less than me. Their score was lower than mine. In other words, so let's call my score Z. The area to the left of my score is 0.46. The probability that you scored less than me is 0.46. That's what it means to be at the 46th percentile. So we want to find the Z-score corresponding to an area to the left of 0.46. Oops. So I want to find my Z-score, knowing that the area to the left is 0.46. So let's go look in my table for 0.46, or as close as we can get to that number. I have 0.4641 here. See if I can get any closer. I'll erase this. 0.46. So, nope. It looks like the closest I'm going to get is this value here. Wait, is that true? Oh, no, just kidding. I can get a little closer here. Wonderful. Okay, so I think this is the closest I'm going to get. So this Z-score corresponding to this is negative 0.10. So the Z-score at the 46th percentile of the standard normal is negative 0.1.